living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. The heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. Screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The streetways are wide, to the world where we glide. From the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. heart of the galaxy where the stars align. We gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hello everyone, my name is Shubham Dash. I am from Bhubaneswar, Odisha, India. I am currently in my second year pursuing Integrated Master of Technology in Mathematics and Computing at IISM Dhanbad. So the title of my project is Eco Explorer for Liquid Galaxy. My project is a visualization based project that will be working on showing the various biomes or the various large forests around the world. Taking a comprehensive look at them, showing their biodiversity, their geographical and statistical informations related to them. Then latter also showing the various environmental parameters like air quality index, the concentration of various particulate matters like carbon dioxide, sulfur dioxide, carbon monoxide in the air, which will create awareness about the environment, the pollution state of that particular forest. And after that I will also be showcasing various catastrophes that have recently affected in form of deforestation. So specifically I will be targeting deforestation and forest fires to be shown in a comprehensive and visualized manner, providing us the accurate details about the foregoings of that forest and what will be its future according to that. So this project is I have a couple of machine learning or AI use cases that I have decided to integrate within this project. So there are two of them. The first one being a voice command or a voice module. So just like the Google Assistant that we can in one command we can simply control everything like call someone or to text someone. Similar to that, I will be creating a voice command that will be supported by DeepGram API, giving us the response that yes, it has successfully responded to our function, which will be switching in between the screens. So if I want to go to home screen, go to dashboard screen, I'll speak something like that. It will take me to that screen, or take me back to home screen. It will understand the text, give me the appropriate response, and execute the particular function, returning the to the some screen. And the second use case is my tour assistant. The tour so as I am trying to implement the visuals of large forests, so I will have the function to take a tour using the Liquid Galaxy rig. So I will be sending tour KMLs to that place, which will show the various points of interest of a forest. For example, Amazon rainforest. So I will be sending a particular tour to that place. Along with that, there will be a voice assistant. So to integrate this voice assistant, I have used Gemma and DeepGram that I will be showing you later to speak like an actual tour guide, giving you the experience of a real tour around Amazon rainforest or any large forest you want to talk about. So let's get going. So here I am ready with my setup. This is a simple execution that I will be showing using my physical device of what are the AI use cases that I will be serving in my application or the project. So first, so I will have two use cases. The first being the tour guide or the tour assistant. So there will be the Liquid Galaxy rig in which the tour will be ongoing, showing the several points of interest or traveling along the path. And along with that, there will be a voice assistant that will be speaking here. So in this, what I have done is, here I have implemented the DeepGram text to speech API along with the Gemma text inference, in which I will give some output. For example, as you can see in my code, I have set up Gemma using the Grok SDK. So here I have set the custom instructions which generate the response as the pure text paragraph describing the geographical information of the mentioned place, and when specifically mentioned, to send the prompt or the message in my generate response when I will be executing the start a tour button. Here I have written, give me information about Amazon rainforest. So suppose for example, I am in my tab of Amazon rainforest and I want to take a tour around the whole forest. So I'll click on the start a tour button. It will send the tour KML to our rig. Along with this, there will be this voice assistant which will be speaking some. I will have in my actual application, I will be having two options. One being story mode, in which it will be narrating fascinating way to small kids, and the other one will be the geographical mode, or mentioning the details of the place that I will be demonstrating right now. So this is an informational part that I will be showing here. So let's click on start a tour. Here it shows tour in progress.
The Amazon rainforest, the world's largest tropical rainforest, sprawls across 9 South American countries: Brazil, Peru, Colombia, Bolivia, Ecuador, Venezuela, Guyana, Suriname, and French Guiana. It covers an area of approximately 5.
Yeah, so now I have stopped it. I will also have the stop option, which will be simulated by this command of audio player, which will be stop speech. Along with the DeepGram text to speech, there is another package named audio players, which will be used to stream the voice, and this will be used to control and then stop the speech also. So when I have to play, I will take the text input. In this case, I have taken the response generated by the Grok inference. Then I will be writing player.play, and then while stopping, I will stop the player coming back to the home screen. So let's understand it step by step. First of all, I initialized my Grok here to the aforementioned API key, started the chat, set the custom instruction, and then by clicking the start a tour button, I generated a response in which I gave the prompt as give me information about Amazon rainforest. It gave a text as the output. Then I gave this text as an input to my DeepGram model, which it spoke from the text using this player. And finally, by clicking on the stop button, the player stopped. Similarly, I will be controlling my whole voice. This is the second use case that I am talking about. I will be controlling my whole application using voice command. So I will have a complete voice module implemented, so that if I speak, go to dashboard, go to settings screen, it will speak something that taking you to the dashboard screen, taking you to the settings screen, and then it will go to the aforementioned screen by using the functions. For this, I have a combination of the core regex functions that are provided by the Flutter. In this case, let me show you the function right here. So yeah, So here the function that I will be executing is change screens. So I will here in this case we had speech text to speech, but in the other case I will be giving my voice as an input, the voice command. So here I will implement text to speech. In text to speech I have already implemented the default text to speech, speech to text, sorry for the confusion, speech to text. So I will be using the default speech to text pubspec package as shown here by Flutter, which will be converting my commands given by speech into text, and as this command reads, command dot to lowercase contains saved. So this is basically a regex implementation or a regex manipulation. If I speak something and it contains the word saved, it will take me, you can see here, like I have bottom navigation bar having two screens, namely home and saved. So if I speak here, take me to saved page, so it will speak, so it will take the command as an input, search whether saved is there or not, and will give the required output that yes, I am taking you to the saved page, I am taking you to this page, I am taking you back to the home page, and then it will execute the required command by switching it to the saved state. As in bottom index we are working with bottom navigation, we are working with indices or numbers. Here simply when I am in home screen I am in the 0th index, and when I will switch to the saved screen I will go to first index. So I will give a delay to this and then switch to my index equals to 1, which automatically switches to the saved screen. So I have for this I have also implemented the speak to text function, which I had already implemented above in my tour function. The same function I will be reusing to just speak a simple text that taking you to saved page to indicate that my command is successful. So let us show it here. Voice command, it will open up a bottom dialog box and I will pick up what the command I want to give. Take me to saved page. Oops, this is the wrong one. Take me to saved page.
Taking you to save page.
Yeah, now it works. So as you saw how easily we switch the tabs from home to saved by using this simple change screen function. So overall this is the implementation that I will be working on in my application as use case of AI. I believe that all the AI use cases that I have shown or I have integrated in my application will be a message sharing the message of accessibility, that yes, even if our certain limitations, we can use a simple voice command to switch to a tab or execute any kind of function, or this is a message for all mobile applications to get forward, making a completely voice based application, so that our specific starting from Liquid Galaxy, it will be accessible to a larger range of person who are for some reason unable to tap or type things inside a mobile application, or specifically in our case a Flutter application. And talking about my overall application, it provides the message to save the wildlife and prevent deforestation, prevent the dispose of various types of waste leading to a decrease in air quality, or creating global warming, producing forest fires. So this provides the message awareness, and apart from that, this is also great research tool for many of maybe forest departments or environmentalists, so they can access this application and a Liquid Galaxy rig to achieve their goals related to various sustainability issues. So that's it from my side. Thank you very much.
Hello everyone, I am Kriplani and this is my submission for Build with AI KASS contest from 2025, and I have built an app called, wait, let me just show you the name of this app. Uh, Galaxy Pilot. It basically control Liquid Galaxy behind me with voice command, and it has also integrated an open source AI model Gemma 2 and Gemma 3 from different providers and also Llama. So yeah, let's just test the app. Here the app start with a cute little 3D mascot. You can just play around with it, just toggle it around, just widget. Yeah, it is just there for the fun. And let me just show you the settings. It is already configured. It is already connected to my Liquid Galaxy, so all the info field are filled, and it also can scan the QR code to connect. And below it are the API settings. There are different provider. Uh, for Gemma or any other open source API. Right now, I am using Grok API because I didn't get the API from Gemini because it asked for billing information which I was not able to provide, and other services I have run out of daily quota. So I will just use Grok and save the API key. The API key is saved, and let's just see it follows our command or not. Mm, okay, let's just check. We all know that Liquid Galaxy show this logo upon successful connection. So we can say that it is connected, right? And let's just see. Clear the logo for me. You just clear the logo. Uh, Take me to Tokyo. It has taken me to Tokyo. Here you can see the place mark as well. Let's just give it a difficult command. Now that I am in Tokyo, why don't you tell me top 3 tourist destination in Tokyo? It is understanding the command. It is generating the KML, and yeah, it is taking us to 3 tourist location in Tokyo. Let's just see what are these locations and if it has generated a somewhat bubble over it or not. Shibuya crossing, yeah, it has generated somewhat considerable bubble. It has some information about it, and it is second location is Tokyo Tower. Let's just click on it. Yeah, here it is bubble Tokyo Tower. And third location is, where is the third location? Okay, I have to zoom out. Okay, here it is. Maiji Sharon. If I hope I pronounce this correctly. Maiji Sharon. So yeah, it has also generated bubbles. But as we all know, there is a token limit. So let's just give it a command which will generate a even longer KML, and let's just see if it generates a error or not. Tell me top 10 tourist location in New York. It is understanding the command. Nothing is happening on Liquid Galaxy. It is still understanding the command. Yeah. And it failed. Failed to generate requested KML because it must be too long, because we asked for 10 location. Let's just check if it works for 5 locations. Tell me top 5 tourist location in Jaipur, Rajasthan, India. The Liquid Galaxy is paused. Nothing is happening. Nothing is happening. It is still understanding the command. Nothing is okay. What it tells yet again. Fail to generate. So I get stuck. Okay, let's just try 4. Tell me 4 top tourist location in Jaipur, Rajasthan. Oh, it again failed. Oh, it failed quite quickly this time. I think I have reached the daily quota limit. But yeah, that's how the app works. Uh, so that was the demonstration of the app. Thank you so much.
Hello community, my name is Vedang Lokhande. I am from VNIT, a college in Nagpur, India, and today I'll show you the app that I have made for Liquid Galaxy Build with AI Challenge. So what my app does is it takes in the name of an event and shows a visually appealing visualization in the LG rig. I have named it History Visualization app, a web app. Herein the user can put in the name of an event. Let's say it could be anything. It could be Taj Mahal or Battle of Plassey, something that is of historic relevance. And what we do is we show some balloons to the user at the rightmost side, and some image that is generated by AI, a few images that would be displayed on the LG rig. And also after the KML is sent and we do fly to the particular location, we hear a narration about the event as if it has happened recently. And okay, so this is the front end of my application. First is the LG connection screen with server address, username, IP address, port number, password, and number of screens. Additionally, I have the Gemini API key which the user can get and put in this field. Then I have the connect to LG button. Currently it's connected, else it would show disconnected. After connecting to the LG rig, you can then use the tools and visualization tabs. The tools tab has clean logo, clean KML, clean balloon, relaunch, reboot, and shutdown options. And the final one would be visualization. Here you could put in an event name. For example, I have put Battle of Plassey. You could put in something that is historical so that you can get information about that historical event. So after I press the send button and putting the event name, this happens.
1957 was a turning point in Indian history. It wasn't a massive military clash, but more of a strategic game. Robert Clive of the British East India Company allied with Mir Jafar, who was eyeing the throne of Bengal, and essentially bought out the Nawab's key commanders. When the actual battle happened, Siraj Uddaula's forces largely stood down, leading to a swift British victory. This laid the foundation for nearly 2 centuries of British rule in India.
Okay, now I would like to show the front end of this application. The first 3 slides would be the first 3 files would be LG connection, the tools tab, and the visualization tab. Here I have the connect.mjs so that I can connect to the Liquid Galaxy rig. The basic index.html that uses modular code formatting so that it is easy to maintain. As you can see, I have used MJS and not React or Next.js so that it is easy for the next generation to copy. Basic styles and some basic JavaScript. So the connection first file would be Liquid Galaxy connection. It has the labels and things needed for the connection along with Gemini API key, some styling needed as well, and a basic button push and API calling. The second is tools.mjs, that is clean KML, clean logo, clean balloon, relaunch, reboot, and shutdown. All of this with the CSS needed, and what would happen on each of the button click. And also I have written the APIs that would be called, and API handling is done in the API section of this file. I'd show the API one by one. The balloon.mjs that calls a clean API, then the clean KML API, logo.mjs so that you can clean the logo, reboot, relaunch, shutdown. These would be the tools.mjs files. Now coming to the most important part, that is the visualization tab code. So it has an input field of visualization event name and send button. So what would happen is when the user enters the event name and clicks on the send button, I am calling an function inside generate.mjs, and I have now made some API in the backend that I would be showing soon. That is the API slash generate API that I have made. So it takes in the basic LG configurations and an additional parameter of event name. And when this function returns true, what I do is I take the description, and what I originally planned to do is make the AI speak in the accent of an old man that would be narrating his story or narrating the event that has occurred in a theatrical narration way. Currently, I am still finding some good accents that could suit this, but as shown in the video, that was the most basic one I could come up with currently. In case the description is not found, it would show a basic set of, let me tell you a tale about something. So this is the basic generate.mjs that would be important, and now I would go on with the backend of the application. Okay, so now I would be showing you the backend that I have made. I have used the basic web server for Liquid Galaxy. This would be the basic setup, and I have added some things. That is, in the routers I have created another router, that is Gemini.js, and let's start. So I have used this package of Google Generative AI that was given in the Gemini API usage and npm integration, and this is used for as a thinking model. The second one would be Google Gen AI modality. This is used for image generation. Then these packages are used for file saving. So let's go to the code. So first is the basic generate API that is called when the user clicks the send button, and the second one is Gen AI API that is used in the generate function. I'd first show you the Gen AI API. So say the user sends an event. Now what would happen is I would try to get an image based on that event, and for that I am using Gemini 2.0 Flash EXP image generation model. So what my code does is it sends an request to this using the API key that is given by me, and this is the code that I have taken from the Gemini API docs usage. This stores the file in the public's assets folder. So say for example, this is the file that was stored, this for the balloon that is used, and this for the camel that would be displayed. Coming back, so as you can see, I am using my host as this because this is the front end, this is the back end that is currently running, and the assets folder, and the file name is randomly generated. I am doing this and saving my file name as some random name that would be later used in my function. Now I will show you the generate API, that is the one that is triggered when user presses and send button. So if API key is not found, you will say that API key is not found. Then we'll check the required parameters. Then what we do is the second model, that is the thinking model, that is Gemini 2.0 Flash Thinking EXP0121 model. So both the models that I have used are free tier models, and they don't require any fees as of now, but when I'll be making my project, I'll be using image models that are paid, so that I could get good quality and high resolution images. So the prompt I gave here was, regarding the event that I am sending, I want its latitude, longitude, and some historical description of the event. Then I get the result, and then I try to differentiate latitude, longitude, and description. Then comes the first step. The first step would be to fly to that particular location using the fly to command, the fly to API that is already made here. After I fly to that particular location with the particular latitude and longitude, what I do is I clean the previous balloons, and what then next happens is I call the image generation API, that is the GenAI API that I have shown before, and I try to get an image for the balloon that I'm using. And after I get the image for the balloon, I'm making this balloon KML. As of now, I am hard coding the balloon KML and then feeding the information that I get from my Gemini API. So the latitude, description, and image, these all things were given me by the Gemini API. So I am not using Gemini API to just give me basic KMLs. Here I am sending the information from my Gemini data and pasting it here, and then say something like this: Battle of Plassey, the latitude, longitude, description, and an image. So what this does is this minimizes the error that Gemini API can make, so that I don't have to worry about more error handling. So now that we have sent our balloon, what we do is we send the KML that needs to be pasted. I feel the image that we are currently pasting is not that high quality, but pardon me for the time constraints. Then we try to we send the show balloon. We use the show balloon API that is already implemented, so that the balloon is sent. We then come to the main image KML. So I make a call to the GenAI, again the image generation API that I have defined below. So in this, I give it a prompt to make a high resolution landscape image that is a bit old, has some river, forest, and elevation, so that it feels like you are dreaming, or you are showing it to a kid that feels more intrigued by what he looks and what is visually pleasing. So I have made this prompt, and I think it would need more fine tuning. So coming next is we send a request to the image generation API. After we get the image, we use it as a KML overlay. So I paste it something like this. So the latitudes, and this is the image that I have got. So I had two options. I could either take the image and get its public URL from Gemini. I did try to do it, but it had some problems, as Gemini wasn't able to handle my request of giving me public URLs to the image. So what I had to do was save the image here and then use it on my LG rig. As this backend works on a NAT network, the LG rig is able to fetch these images, and it is able to display them as href. So href for the images that are given. So next comes the send KML code that I have taken from the already done KMLs. So what we do is we try to do a form append and then send it over using this API of send KML with the body of form data. And when I get this would be the basic error handling. Yeah, so the 5 steps I told, I'd like to summarize those 5 steps. So that would be receiving an request, then validating the inputs, then we get the coordinates and description with the Google Gen AI model, then we pass those responses in the balloon, then we fly to the location and clean previous balloons. Then for the balloon that we want to show, we make an API call for the image of balloon and then save the image in our server and then use that image as href in the balloon and send the balloon. Then we get an image for KML using the same API key, and then we save it again and use the href for the KML of that particular site, and then we return that response to the user. And the basic overview of Gen AI endpoint would be getting the request, that is we get an event name of the event that we want to create an image, then the API key, and then it generates the image and saves it locally in the server. What happens is we get an base 64 image that we have to store in our server byte by byte and then return the response to the client with the image URL, that is the image URL with respect to the server. So for example, if my image is this event with a number.jpg, so it would be accessible at localhost 3000 /assets/ this name. So that would give you the image. So this was my original inspiration that I planned to make. As you can see, this has some immersive and historically looking and visually pleasing graphics. This image was generated by Gemini. I see that there is a certain level of resolution that Gemini provides. So I plan to use and create some better prompts so that I can create images of this format. What I plan to do is creating several images, around 3 to 4 images, stitching them together and then sending them to algeric SKML. And what would happen next is my AI would tour it based on the prompt given by the user or as generated, so that the tour would go here and let's say here and let's say here, something that is AI generated and not done as of now. So I would like to also tell that the AI voice that I have planned to use would be something similar to this that I'm going to show you, that is Grandpa Studs Oxley that I have tried to find. So this is 11labs.io and it has various audios that I can get. Some are even for free, and let's see.
Let me tell you what my grandpa told me when I was just 6 years old. Son, always speak the truth. People will never forget what you say.
So as you can see, it would be a lot better if I had something similar to this that would be narrating the story of the event to us, that would make us feel like, let's say you are a kid and you like to hear some stories. So I have made this app keeping in mind this particular scenario.